Hello, good morning, and welcome to another session in the series Programming Daily. Today I'm excited to work on drakon-renderer again. Just to recap, yesterday we managed to finish preparing the data structure for testing out my new layout algorithm, and the data structure is presented as so. It's a list of lists that it gives a better idea of the depth of the diagram. So it is divided by levels. If we were to revisit this diagram, just to recap, this is level 1, this is level 2, level 3, this is level 4. When I mean level, I mean list with index level plus 1, because the index usually starts with 0. Here we have level 5 with 3 icons, etc., etc. Now, I'm excited to make another step into the implementation of the new algorithm. And what I'm thinking would be reasonable is to, as we have a collection like that prepared, we take the first item of the first row. We take the first item of every row and we render that. So the function I have in mind, well, obviously as the first step. Later on, you'll see how you'll see what my thinking is when it comes to the new algorithm. But let's take it step by step. So in the first place, let's go to the main function where we present the dependency plane. Up to date. Let's make some room for the new positioning. And the new function that I have in mind is going to work something like this. Let's not give it a very distinct name for now, but it should take the dependency plane, aka the list of lists of icons, and it should return a list of positioned icons. And that way, we should be able to start rendering straight away. So from the dependency plane, I believe we can just do a list comprehension. And for that single level, we do so what this needs to produce is, for each level, we only take the first icon, if it exists, and we translate this icon into a positioned icon. So in that case, I believe what we would need is some sort of an index or accumulator that we could assign to the to the y coordinate of the positioned icon, we know that the x-coordinate is going to always be 0. So what would make sense to me is to make this a recursive function. So for that dependency plane, let's write a helper function that takes a row of icons. Oops, sorry. And it returns one positioned icon. Or a maybe one positioned icon. Okay. So here we want to do if the row is empty, and it could very well may be empty as we progress down the algorithm. We return nothing. is, icon is. First icon. So we have a function that extracts the first icon from a row. You know what? Let's try to build it. Oh, sorry. Obviously, we need to translate it into a positioned icon. Let's take a sneak peek how other functions do it. So here we can just do I. And if everything works with this new algorithm, I should be in the position to remove the dependency on the directed graph library, which I find pretty appealing. So icon is I, position X. Now we'll need to supply this. XY. this should be just. Oh, sorry. Oh, there was some good hints there. So IS is not required. That's right, we can get rid of it. Oh, there's a function called non-elm. That's good. $139 in records. Did I not save it? Oh. I suppose that is looking a bit better. Let's see, other suggestions? I'll resolve all these warnings once we have the core of the algorithm in place. For now, let's focus on most important things. And this is calling this function first icon. So we know it's working. Now, in order to be able to call first icon with those two doubles indicating coordinate x and coordinate y, we need to have some sort of accumulator that tracks the depth of the dependency plane at which we are currently at. So here, alongside the dependency plane, we can probably also have have an index, or we can just generate an index from 0. I believe this is how it's done. Let's call it an I. Is this the syntax for indexing a list? Looks like it. No, sorry. Let's do push it down. And here, I believe we should simply call first icon with the row and also with let's do this. So the problem I'm facing now is that even if I wanted to pass the 0, 0, and 0, or sorry, 0, 0, minus I still need to convert I to double because it's an integer or integer and I need a double. So if I compile this, it will probably complain that I'm trying to use an integer where there should be a double. I almost got it right. And I can't do it with a list comprehension because it needs to produce the same number of positioned icons as so if you give it n inputs, it will produce n outputs. I think I need to use a fold instead. Or a good old recursion. And here, for now we can just leave a 0 here, and this can be substitute with depth. Of maybe not. And here you just need to call it recursively ABC, remaining rows and depth -1. And in this case, again, and I hope this should work. Let's see. Oh, dependency plane. Current row. Now we obviously need to call this. Redundant bracket. This is nice. Let's make some room between the two. Define but not used, define but not used. What do you mean? It's not used. I was under the impression that it is used. I was under the impression that it is used. Strange. This current row could be empty. But for now, let's not get distracted. Let's try to call this ABC. Well, we know the dependency plane works, so we don't need to print it. But what we can do is, let's call it first column. So here it should not be records, but layout engine now, and dependency plane, and we start from y equal to 0, and then we print dependency plane. Sorry, not dependency plane, first column. I think we need to export it. It looks so elegant. Layout engine, export function, Cartesian positioning, and also ABC. So what we do expect to see is a row of 8 icons, sorry, a column of 8 icons from start to finish, from title to end. And that will be the first iteration of my new algorithm. And if time allows today, I'll try to explain how I'm thinking to implement the rest. Now, we could use more screen space here. So we should have a list of 8 icons. Icon 2, headline, that's correct. So as I'm formatting this, I might as well quickly explain how I want the new algorithm to function. So in the first iteration, we take the first available column in the list of lists. This is the first sort of family of dependents, like the first dependence. In the second iteration, we go through the list of lists, or the dependency plane, and we scan from the bottom. We go up and we say, do we have a we go from the bottom, but we only scan the first available column in the second iteration, which would be the second column. In the second column, we say from the bottom, do we have an icon that is a dependency of something that's already in the list of positioned icons? If not, leave it be. If yes, add it to the list of positioned icons and also add its first row of dependencies, or first sort of column of dependencies, just like we did with the first row, the first column, just right now. And repeat the process, progressing from left columns to right columns. That's sort of my high level thinking. I've done some experiments on paper and it seems correct, but let's verify. So if we sort these icons, if we order these icons, we should expect 8 rows forming the first column of the diagram. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. And each of the elements in this list should be the first dependent of the previous icon. If there is more than one. If there is only one, it should be just the dependent. So let's just double check. Icon 0 depends on icon 1. Icon 0's dependent is icon 1, which is rendered. Icons 1 dependent is icon 2, which is here. Icon 2's dependent is 3 and 4. Now, I've added 4, which is not correct. I should have added 3, but we can easily correct that. Icon 4's dependent is 9. 9 is added. Icon 9's dependent is 8. Is 8. So the next one should be 8, but because I took 4 here instead of 3, let's see. So 4 is added here in the first set. This is not correct. They should be sorted. So if dependencies are 3, 4, they should be also in the same order in the list of lists. So these should be flipped around. So my algorithm for positioning dependence has a little hole in it. I think it should be here. Oh, sorry. All right, here we go again. 0 should be first. I'm really interested in icon 2 now and its dependence. So this works because each of these icons so far only has one dependence. So here I have 2 dependents. The next level should be icon 3, and it is. Perfect. So 5 prime 6. The next icon in the list I'm expecting to be 5 prime. And it is 5 prime. The next icon in the list I'm expecting to be the first dependent of icon 5 prime, which is 5. Perfect. And here 5a, 5a, and 8. That's it. So we have our first column. This is good. I'll just leave a comment. No longer up to date, but leaving here. So you know what? I think we're ready to render second column. Okay, let's do this. So I'm going to start and substitute. Positioned icons with alternative positioned icons. And let's see how this works. I can do some cleanup later. So all right. It looks like the first sweep of my new algorithm is working. So we have title, headline, 2, 3, 5 prime, 5, 5a, and we even have connections rendered correctly. Now, this is very encouraging. What I will be doing next is I'm going to call the algorithm recursively, this ABC function recursively, and I'll be going column through column until I find and position all dependents. Now, I would like to thank you for your patience today and for sticking with me, and see you during the next one. It should be very interesting.